Welcome to my YouTube channel. Today my class is the welding joint subjected to bending moment, which is denoted by MB. Here MB equal to bending moment equal to load into eccentric distance E, P into E, which is Newton millimeter bending moment. Now here this is a bracket frame. There are two welds, which is parallel fillet weld I like. Then the fillet welds are joined together. There are two fillet welds together by the bracket frame. This is a cantilever beam where the load is applied P about the eccentric distance E. Now we calculated the maximum shear stress after applying the all formulas. First figure, we saw that the figure B, this portion is expanded here. Now the first P is eccentric distance E and two welds which is known as the W1 and W2. This is the center of gravity G where the load is applied. When the load is applied, then it will tend to rotate the job and it will break due to shear stress. First we apply the load, combination of the bending moment and the load. Here the combination figure is here and expanded figure is here. There are two portions. First the load is applied P. Due to load, the shear stress, the fillet weld thickness of the throat is break due to the shear stress applying the force P, and also the bending moment which is rotate the part and it will tear due to the bending moment and it will act at normal stress. By applying the equation sigma B equal to MB into I by I is the summation of the moment of inertia, Y is the distance from the neutral axis, center of gravity to the neutral axis, which is the T. Here T is the T by 2 and this is T is very small, then we have taken Y1 equal to D by 2 when calculating the equation. Here the fillet weld tear by the bending applied load, which is MB, and bending applied load is P at a distance of eccentricity E. Therefore first primary shear stress we can find out by the applying the load applying by area. Then this is Newton per millimeter square and P is the load Newton, and area equal to area 1 and area 2, which is the rectangular shape, then B into T, also here B into T, therefore 2BT area, here P divide 2BT area. This is the area when applying the load, then it will stress will develop. Here B is the length of the weld in millimeter and throat thickness T is also in millimeter. Now applying parallel axis theorem from the center of gravity G. Here the parallel axis theorem, this is the IG where the passing through the neutral axis and from a distance Y, which is distance is the D by 2 length. Therefore parallel axis theorem equal to IG plus area into D by 2 whole square. Therefore IG equal to B into, this is B into T whole cube divide 12. This is Ig of the rectangular cross section moment of inertia when the passing through the centroidal axis is passing through the neutral CG, and B area equal to B into T into D by 2 ka whole square. Here T is very small than width B, I length of the weld B, therefore T is neglected. Now the only second part is using for the IXX, which is the parallel axis theorem. Therefore Ix is equal to Bt into d by 2 whole square. Therefore Bt into d square by 4. Here two parallel fillet welds are here, where the bead welding operation is carried out. Therefore Ix is equal to 2 into this Bt into d square by 4, and this value is thickness of the throat weld into Bd square by 2. Now the bending stress sigma equal to, equation is Mb into y by Ixx. Then this Ixx equal to this value. Mb is equal to, I saying earlier, P into E, Newton millimeter, and y equal to, this is the distance from the whole distance divide half, then d by 2. Therefore maximum shear stress at the weld joints, which is applying the maximum shear stress theory, tau equal to root under bending stress sigma b by 2 whole square plus tau 1 whole square, where tau 1 equal to, I have calculated earlier, P divide area, Newton per millimeter square, I P divide 2 Bt. From this formula we can calculate it maximum shear stress. Thank you. लेकिन इसको बंद मत करना. We take some dimensions and parameters of the calculating the values of this. There I like the load P equal to 25 kilonewton, shear stress level is 80 Newton per millimeter square, the eccentricity is 100 millimeter, and distance d equal to 100 millimeter. Therefore y equal to distance d by 2 equal to 50 millimeter, and b is the width of the weld length equal to 50 millimeter. Therefore applying the Ixx, this formula is Tbd square by 2, and this value is 250000 into T millimeter per power 4 Ixx, and the bending moment Mb equal to P into E, 25 into 10 to the cube into 100 mm, E equal to 100 millimeter, and here 25 into 10 to the power 5 Newton per Newton millimeter. Area equal to 2 Bt equal to 100 T, and finding the primary shear stress tau 1 equal to P by A equal to 250 by T Newton per millimeter square. Again the bending stress sigma B, applying the sigma B equation, M by I sigma by Y formula, then this value is 25 into 10 to 5 into 50 divide 25 25000 into T. This is the value. Again the sigma B equal to, we get 500 by T. This value, these both values are applying in the maximum shear stress theory. Tau equal to sigma B by 2 whole square into tau 1 square. This value is, we root under this value, put, and we get 353.6 divide T Newton per millimeter square. Stop. वो वाला